In this section, we'll state the order of operations for expressions involving conditionals. We'll also look at constructing the truth tables of two examples involving conditionals. As a recap, it's helpful to remember that the output for P implies Q is TFTT. When constructing the truth table for P implies Q, look for the rows where the hypothesis is true and the conclusion is false. The output for those rows should be F. Then fill up the other rows with T's. Before we proceed to construct the truth tables for statements involving conditionals, it is crucial to note the order of operation in relation to all the other operators we have learned so far. Always do not first. Next comes and or. Then comes the conditionals. As usual, brackets will override all the other operators. In this example, we will construct the truth table for this compound statement. Step 1. To set up the rows, we can see that there are only two inputs, x and y. So there should be only 2 to the power of 2 rows. Now, let's set up the 4 different combinations. First input gets 2 t's and 2 f's. Second input gets 1 t, 1 f, then repeat it. Once that's done, we strategize for step 2 according to the order of operations. Since bracket supersedes all other operations, we will do these two smaller components first, then consolidate everything at the end. The first component, x, implies y. That's a conditional. Remember TFTT? The hint is to pick up the cases where the hypothesis is true and the conclusion is false. Those are the only cases with output F. The rest of the rows will have output T. In this case, the only row where X is true and Y is false is row 2. So the conditional X implies Y gets a false. The rest of the rows will get T's. Now the second component is x and y. That's a series circuit. The only row where x is true and y is true is row 1. So x and y gets a true. The rest of the rows will get f's. To consolidate and get the final output, we notice that the main operator is a conditional. The hypothesis is in column 3 and the conclusion is in column 4. Remember TFTT again? The rows where the hypothesis is true and condition is false are rows 3 and 4. So the output is false. The other two rows gets output true, and the truth table is completed. In this exercise, we are to prove or disprove the logical equivalence of these two expressions. But first, let's set up a truth table with 2 inputs and 4 rows, like this. Before setting up the columns, consider the order of operations. For the first expression, we should do not followed by or followed by the conditionals. For the second expression, we should do not followed by or followed by the conditionals. Now suppose that the intermediate steps have been done up for us. How do we get the truth value for this? Notice that the main operator is an imply sign, and this blue column is the hypothesis, and this pink column is the consequence. So let's pick up the cases where the hypothesis is true and the consequence is false. those will be the cases with the output F. The rest of the rows will have output T. Next, to get the truth value for this, notice again that the main operator is an imply sign, and this blue column is the hypothesis, and this pink column is the consequence. When we try to pick up the cases where the hypothesis is true and the consequence is false, we find that there are none. Hence, all rows will have output T. To check for logical equivalence, compare the two output columns. The first row has F and T, and the second row has F and T. So rows 1 and 2 have different truth values. Therefore, they are not logically equivalent. In summary, it is helpful to remember that the output for P implies Q is T, F, T, T. When constructing the truth table for P implies Q, look for the rows where the hypothesis is true and the conclusion is false. The output for those rows should be false. Then fill up the other rows with truths. When it comes to the order of operations, always do not followed by and or before doing the conditionals. Brackets will override all other operations.